Hi, my name is Vanessa Baker, and this is the application video for the lecture from November 7th. So the example for this video I'll be using is a mass on a spinning chair and showing how once the velocity of the chair is greater than the maximum angular velocity, it will overcome the static friction and the mass will fall. So some assumptions for this example, we're assuming that there is a constant omega, so the chair is rotating at a constant angular velocity, that the mu naught of static friction is mu, and that the following coordinate system is used. So first, to solve this, we'll use a free body diagram to model the forces, and then we'll solve for acceleration using the BKE. And finally, we'll solve for forces using Newton's second law and isolating the components into their respective a hat 1 and a hat 2 directions. And then to find omega max, we are going to use the force of static friction equals the normal force times mu, because anything larger than that, the force of friction will turn into kinetic friction and the mass will move off the chair. So when plugging in this mg for normal force into the force friction, we find that omega max equals the square root of mu times g divided by L. And a note for this equation is that as L increases, the omega needed decreases. So in other words, as the mass gets further from the rotating point, less rotational speed is required to take it off the chair. And this can be shown in the following videos. So since the mass is close to the center of the chair, it requires a faster angular velocity. And since the mass is farther from the rotating point, it requires a smaller angular velocity. Thank you.